Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. We also have a polling question during today's webinar, so hopefully we can get everybody engaged. And at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Service Mesh. 2 big words, but do you need it? Our speaker today is Ravi Vagadia, who is a NGINX Solutions Engineer at NGINX, part of F5. Ravi, thanks so much for joining me today. Really appreciate it.
Thank you.
Okay. So I know you've got a great presentation on tap. So I'm going to put myself on mute, take myself off camera, and let you get right to it.
Sure. Thank you. Hi everyone. Welcome to NGINX. Welcome to the Service Mesh webinar. Thanks for joining us. I'm Ravi Vagadia. I'm Solutions Engineer at F5, part of NGINX team. I've been working with distributed systems for about 10 years, and pretty much the entire career I've been a user of NGINX. I've worked with startups mainly around building, products in the areas of IoT. So with that, let's start. Today we are going to, discuss about NGINX, about the modern application overview. Service Mesh, what Service Mesh is, and how it can help you in operating or building your distributed applications. We'll also look at some of the gotchas and kind of things that you should be careful when using Service Mesh. And we'll also have a short demo of NGINX Service Mesh in action. So let's start with modern application overview. So what kind of applications we build today, or we are going towards, is something that that are getting more and more, I would say, distributed, more and more smaller and dynamic. With the what we see in the market is that with the increasing use of Kubernetes, it becomes much more easier and simplified to deploy and manage this dynamic microservices-based applications, which was normally, I would say, a little bit painful before, pre-Kubernetes world. Now, what we also see is that, not only the operations part, but also from the development standpoint, right? You have applications that are built in a completely, containerized Kubernetes kind of environment, and you have your CI/CD and automation systems also sitting right there inside the cluster. That's where the applications are deployed. And with the popularity of Kubernetes, there are many many managed Kubernetes services that are available, which makes it even more easy to get started on a platform like Kubernetes. Now, if we look at who is using microservices in productions, based on the survey that NGINX did, we see that there are 40% of users who are actively using microservices architecture. They're building their applications using that and putting it in the productions, and almost 37% they are planning to either build an application or migrate to a microservices architecture, and migrating towards more like Kubernetes environment. Now, if you look at general attributes of moving from a monolith to microservices, some of the things like you have traditionally we have a monolithic application, one binary, very easy to deploy. Now we break it into multiple services. The good part is that we are able to manage, develop concurrently different parts of the applications, which greatly improves the time it takes to build the entire application. And then we have, from moving from the traditional protocols like, SOAP, XML based protocol, we are moving towards much more leaner, lightweight, efficient protocols. There is a significant rise in, there's an uptake in gRPC and GraphQL based protocols as well. And then we are also moving towards more like, fixed, instead of doing it in a fixed set of capacity, we have much more immutable infrastructure. We are comfortable, spinning up, spinning down the infrastructure, adding capacity as required, reducing it when not required, right? And instead of doing the more, I would say, planned or, more of a periodic releases, what we have is much more sort of a continuous delivery kind of a setup. So all these are, great, I would say, benefits of doing, microservices, modern applications. But, there are some of the challenges when it comes to developing or operating these kind of systems. Now, if you are working with a development team, and if you are building these microservices applications, then you must have seen there are a number of times issues which are purely related to how these services talk to each other. Because we have, instead of doing the normal function calls, we are doing the function calls also over network, and then there are certain things which are not assumed to be true in case of things or operations happening over network. So sometimes we have, let's say, you make a function call, or you try to invoke an API, but the other microservices may not be available, or may send a delayed response, which impacts the performance of the overall system. And debugging is much more easier when you have a a monolithic that's you can just developers can just start the application, put a breakpoint, and debug any issues that are there. With microservices, what you have to do is spin up a bunch of services which are which your service may be dependent on, and then it becomes much more complex to debug. So overall, moving from the development world to operations, when we are operating these microservices in production, it gets much more interesting, because normally we do have visibility in terms of how the application is performing from the user's point of view. But if we want to go a level deeper and see how all the services talk to each other, what is the error rate amongst the microservices that are talking to each other, then it becomes much more difficult to do it in a manual way. We can still do it. We can still put up proxy with each of these applications, collect metrics, and can be done, right? But it becomes much more of a complex job, since there is always going to be increasing in number of microservices that are there, and then the number of instances each microservice may have. So with that, that's where the service mesh comes in the picture, and that's where service mesh tries to make the life much more easier. So what is service mesh? There's a nice definition from the new stack. Service mesh is essentially all about taking control over traffic, and improving or managing security and observability in a much better way. So normally this is a high-level view of how the traffic would flow inside a Kubernetes cluster. So you would have a external load balancer sending traffic to an ingress controller, and then that traffic is basically routed to the service, and service decides where to send it. So all the L3, L4 networking is taken care by Kubernetes. What happens is we still need to make some decisions based on the L7 traffic. So things like HTTP headers, the URI path, those kind of things, and that is where an ingress controller would come in the picture, right? So service mesh is all about basically monitoring or routing traffic or managing traffic that is between the pods or between the services that are running inside the cluster. So it normally doesn't deal with any external facing or traffic that is routed from the outside world, which is normally called north-south, right? The service mesh it deals with the east-west traffic. So how does the service mesh work? So normally there is a sidecar that sits along with all your microservices, or think of them, if we say one instance of microservice is running inside a container, then you have a sidecar running along with your each instance of your service. And then there is a sort of a control plane which configures these proxies to basically apply the policies. So service mesh is not a one component. It's a set of components which work together to bring that security, visibility, and ability to have a fine-tuned control over traffic. So as we saw in the earlier diagram, because Kubernetes has visibility at layer 3, layer 4, of the networking side, the service mesh has a much higher, because it's a proxy sitting along with your application, it has a much higher visibility, meaning it can see your jot tokens, make some decisions based on that. It can have full visibility of the headers, and then we can basically decide if based even on the content of the request. So that's the level of flexibility that we get with the service mesh. So essentially it's all about observability, securing the traffic, and managing the traffic. Now if we look at some of the high level use case any service mesh is built for, is to provide some sort of security or secure communication between multiple services. So think about a microservices application that has maybe 50 or 100 microservices. Now you want to ensure that each of these services communicate with each other over TLS. Now the complexity over here is that it can be definitely done with some sort of automation tools and configuring the proxies manually, putting the certificates. However, all these different microservices, they are generally not written in one programming languages. It's written in different or multiple programming languages. So what happens is that you don't have a consistent way of managing certificates and doing all sorts of ensuring that all the services comply with the certificates and key exchange. That becomes a much more complex job. And now compare that with the service mesh approach, where you have a proxy sitting with each of your microservice, regardless of which technology or which programming language the service is written in. So what happens is you have a control plane which can go and install the certificates on all these proxies. Makes it much more easy to manage. Now the other part is the powerful Kubernetes APIs that gives a source of truth for how your application is deployed. Control plane can query the Kubernetes APIs and get the information about your microservices and how they are deployed in the cluster, and make the updates or decisions based on that. So let's say if you deploy a new microservice, it may not even be using HTTPS. It's all abstracted. So NGINX, or a service mesh that's running inside the cluster, will basically monitor the Kubernetes APIs and apply those changes transparently. Now with the layer 7 visibility, what we can do is we can do things like load balancing and A/B testing, canary deployments, rolling releases, and all those things, even for the microservices. So now it's quite I would say common for doing all those things for the entire application. But sometimes you may want to have a particular a particular version of a microservice to run along with an older version. So in that case, you still need control control over traffic when it comes to internal communication between those microservices. And another factor is the observability part, where since you have a proxy that is sitting along with all your containers, we get a kind of a unified way to capture the metrics and plot it in tools like Grafana or other monitoring tools. So that gives you a kind of a clear view, a unified view of how your application is performing. Now, I mentioned sidecars a lot of times. So what is a sidecar, right? So, like if you are familiar with Kubernetes and you know what a pod is, then a pod can run multiple containers. Now, sidecar is essentially another container that is running along with your application. Now, normally for the service mesh use case, we generally only take care about the networking part. But sidecar is a general concept, could be used for like collecting logs or doing some sort of monitoring. So there could be multiple use cases that a sidecar can be used. For service mesh, it's an ideal place to inject a proxy which can reroute all the traffic that's coming to the pod or going outside the pod via the proxy. Now that means that we are able to monitor not only the incoming traffic, but also the outgoing traffic. Now, if you look at normal application, let's say this is a microservice that's running inside a container. What happens is that we can put a proxy like NGINX Plus, and then since all the traffic passes through NGINX Plus, we can do a whole sort of things like authentication or service identification using certificates, things like collecting metrics. So so the question is how are the sidecars deployed, right? Now, normally you would have a YAML file with your pod spec and a container definition. One of the manual ways of putting a sidecar is to add another block of container, which could be NGINX or any data proxy, and then you can basically configure that pod to reroute all the traffic incoming and outgoing traffic to pass via that proxy. So that's basically how it works. Now, normally, it is possible, doesn't mean we should do it manually. NGINX or any sort of service mesh will have a control plane which can monitor whenever these YAML files are deployed on the cluster and can automatically inject the sidecar proxy. Now, sorry. Looking at some of the use cases, what we have is, let's say, without a service mesh, how a traffic would flow. Let's say you have two pods. Now this pod wants to make a connection to port B, right? What happens normally is that all you need is the IP address or the DNS name for this particular port and can make a simple connection. Now, this could be an HTTP connection or HTTPS, depending on what the port B expects. There is no control, there's nothing uniform over here, and it's if it's HTTP, it's all plain traffic that's passing through amongst both containers. Now, if we look at the service mesh traffic flow, what happens is that the control plane will basically send the key and certificate details to the sidecars that are running alongside your container, and these sidecars will configure itself using this credentials, and then any traffic that passes through the sidecar is by default encrypted. Can be applied certain policies where we want to say maybe port A should only be able to talk to port B and not any other services. So all sorts of traffic policies are possible with this kind of approach. Now, if we look at controlling the traffic, so let's say and since NGINX Service Mesh over here, what I have is a SMI spec. So SMI is a service mesh interface. It's a standard specification on how to handle how to apply traffic policies. So what we have here is certain percentage. What I defined here is like 100% of traffic should go to this particular service, and 0% to this one. So whenever there is a connection, it's not going to go to target V, it's going to go to the target V2. So that's how the traffic flow happens with the sidecar proxy. Now, if we look at collecting the telemetry data, and over here, what I'm trying to show is an internal communication where port A tries to make a request to port B, which in turn makes another request to port C. So what we see here is that whenever there's a connection, there is going to be some telemetry that is going to be collected and stored or sent to something like Prometheus or Zipkin, and then same thing happens for the each path in the proxy. So with this approach, what we get is complete visibility on how the request was routed, where was the latency added, or if there was any errors, we can also visualize that. Now, in terms of policies, since what we've seen is much more of a foundational blocks. Now, if we talk about policies, there could be purely layer 3 kind of policies that we can do, like don't allow a connection to a certain IP addresses, or don't accept connections from a certain IP addresses, those kind of things. Then there are, of course, the traffic policies that we saw earlier. We can validate JOT tokens using, because the proxies will have full visibilities in the incoming request, can extract the headers, visual, or perform some operations based on that. Things like checking whether what's the claim, and based on the claim, if they want to if it wants to process request or not. Now, all of this without making any changes in the application, and without any sort of complexities of implementing same thing over multiple services. So this kind of approach greatly makes the service lighter from the logic point of view, where developers, they don't have to worry about the traffic management aspects of operating a microservices application. Now, I would like to show how NGINX Service Mesh works, and it's pretty similar to what we discussed. So let's say you have a set of infrastructure where your application is deployed, and you have a set of microservices that are running on this infrastructure. And we have control plane, Kubernetes control plane, which basically takes care of scheduling all these containers. Now, what we do is we inject a sidecar for each of your services. So let's say you have 10 services, we put 10 NGINX proxy along with the container. And now, since this proxies needs some sort of configuration, right? And this, because of the dynamic nature, we may want to configure these proxies on the fly, like let's say rotating the certificates or any change in the traffic policy. So what we have is something called NGINX control plane, which sits inside the cluster. It's a very lightweight control plane which talks to the Kubernetes service registry, gets the details of all the services, ports, and endpoints that are deployed on the cluster, and it has a CLI or API which can be used to send the commands to the NGINX control plane. So this is where the control plane is made aware about the desired state, and control plane will basically push that configuration on the proxies that are running. Now, what we have is some of the open source components that we use for NGINX Service Mesh, things like Spire for service identity, Grafana, and Zipkin for tracing, for visualization. And we also have a ingress controller which can work both as ingress and egress gateway. So any traffic that is coming inside the cluster is handled by the NGINX ingress controller, which is a very popular ingress controller in the Kubernetes ecosystem. And then for any outgoing request, so for example, if you want to only allow your service to talk to a particular API server, then you can create a policy. And even if your container, for some reason, if it's compromised, if there is some sort of attack, and someone tries to use that as a proxy to trigger a larger attack, then it will be blocked, any outgoing request which does not conform to the policy. Now, we also have NGINX controller that will allow you to manage all these services. So to sum it up, what we have is a set of APIs or expose that control plane exposes. So it makes it easy to integrate with the CI/CD pipeline. And for managing any external or internal or north-south traffic, NGINX Kubernetes ingress controller can manage that. and it talks to all these services that are running inside the cluster. So you have a complete integration between the east-west traffic and the north-south traffic. So things like end-to-end MTLS, all the way from your load balancer, external load balancer to KIC, and KIC to all the services that are running there. And in terms of the components, because these are some of them are open source components, it's very easy to customize and build on top of that. Now, some of the features that we discussed. So what we have is a zero trust kind of model that we can implement. So with Service Mesh, because we get full control over the communication between two services. Having something like MTLS configured is a one step towards going towards the zero trust kind of architecture, where you don't want any internal service to be trusted by default. So we can create strict policies where we are able to specify which services can talk to which other services. Not only from the from the layer 3 point of view, even from a layer 7 standpoint, what we can do is things like rate limiting. For example, if you have a less critical service which maybe sending a lot of requests due to some bug or some issue, can overwhelm some critical services that are running inside your cluster. So when you have full visibility in terms of the layer 7 traffic, we can inspect the headers packets and know which where it's coming from, and applies rate limits, controls, sensible controls, so that it doesn't overwhelm any critical services. And then we have support for the ingress TLS. So same thing can be, same sort of policies can be applied for any internal facing traffic. Internal meaning the traffic that is routed from the load balancer to the cluster. And for the entire cluster, we can set policies on how they are how the services are allowed to communicate with the outside world. With the integration of ingress and egress gateway, what happens is, the way it works is that there is a Spire Spire instance that is running on each node in the cluster. And since all these proxies that Spire is responsible for generating service identity certificates, rotating those certificates. So Spire basically works as a TLS search store, and then all the components inside the cluster, they use the same source of truth for configuring themselves and use the correct certificates. So no more forgetting to renew the SSL or TLS certificates, especially for the communication that happens inside the services. Now looking at some of the features, like what NGINX Service Mesh can do is do full sort of traffic management, things like circuit breaker, where if let's say there is a service that is down and too many services are trying to access it, we may want to reroute those requests to some other service. We can do blue-green deployment, things like A/B testing using canary deployment, and of course the weighted distribution of traffic amongst the services. And then because the control plane which runs inside the cluster has full visibility over the state of the application, we are able to know each container and the endpoint IP addresses. So NGINX can be configured to do a more fine-grained control over how the traffic should be routed, even at a container level. And then in terms of operational footprint, so one of the key advantage of NGINX Plus is it's a very lightweight and high performance. So the NGINX proxy itself is a small Linux binary, so it doesn't add a lot of overhead on running as a sidecar. And then the control plane itself is one binary with some few open source components, and they will talk to each other with a minimal kind of operational overhead. So you don't need a lot of resources to run NGINX Service Mesh on the cluster. So with that, I would like to show a quick demo of NGINX Service Mesh in action. But before I go there, there is a poll that you can answer while I set up my environment for the demo.
Yeah, I'll go ahead and push it out right now. The polling question is, with regards to your organization's app infrastructure, what statement holds true? You can select from combination of legacy monolith and microservices deployed, fully microservice-based infrastructure but not service mesh, started to deploy service mesh with Istio and/or other tools, fully deployed service mesh and happy with it, or fully deployed service mesh but with issues. You can go ahead and make your choice. And while we are waiting for everybody to take part in the poll, just a quick reminder that we are taking questions from the audience for the question and answer period, but you do not have to wait for the question and answer period. If you do have a question for Ravi, just go ahead and use your GoToWebinar control panel and submit your question at any time. And we should have some time near the end of the webinar to go through audience questions. All right, so looks like we'll go ahead and close out the poll here in about 10 seconds. Just give folks just a couple more seconds to make their choice. Okay, closing it down in 5, 4, 3, 2, 1. Okay, let's go ahead and take a look at the results. Looks like the majority of folks have a combination of legacy monolith and microservices deployed in their organization's app infrastructure, which is, I think it's kind of interesting, Ravi. Is this what you're seeing in the market with your customers?
Right. I think it is in line with what we see. The reason I think one of the and it's interesting because it's not possible to migrate everything to microservice. It's sometimes because there are applications which are battle tested, they are running from quite some times, and you don't want to disrupt those applications. So it's a slow process, and this is also where one of the interesting bit is that some of your services could be running inside the Kubernetes cluster, and some of your services, the legacy ones, they may be running in some other kind of infrastructure. And with NGINX, what we have is, it's possible to, monitor, deploy service mesh in the Kubernetes clusters, but then you also have, your legacy applications. And if you put a proxy with those applications, we are able to extract the same set of, metrics, same way of, managing those different services. So yeah.
All right, great. Well, I'll go ahead and hide these results and let you get back to it.
All right, so let me show the NGINX Service Mesh. So the components, as we saw earlier, there is one control plane that is deployed in the Kubernetes cluster, and NGINX Mesh CTL. This is a command that is used to communicate with the control plane that is running in the Kubernetes cluster. So what we have is NGINX Mesh control is basically it uses the kube control config to figure out your Kubernetes cluster, and then when we run it, basically in this case it just checks whether the connection is successful or not. Now if I look at help, I have some of the so one of the design principle for developing NGINX Mesh Service Mesh is to keep it simple. Just it should just work, and there is very easy to use control interface, which is both the CLI or the APIs. So there are REST APIs for all the operations that we can do using the mesh control command. So over here, what we have is few of the commands, very simple. If you are deploying this to a new cluster, then just have to deploy it with the right set of container or container registry that's pointed to it. And then on the config, we can see the current configuration of the service mesh. So let me quickly show the current configuration. Over here, what I can see is the sidecar image that is used by the control plane when it's injecting a sidecar. And for tracing, I'm using a Zipkin. Now this Zipkin, so NGINX Service Mesh can install a Zipkin instance, and a Prometheus Grafana instance is by default. but sometimes you may already have an instance which you want to use. So can be specified here when deploying the service mesh. Over here, what I have is the same thing for Prometheus can be deployed, with an existing Prometheus pointed here. And this is the NGINX Service Mesh API, and it's an internal FQDN. So this is I would say, the brain of NSM or NGINX Service Mesh. This is the APIs which the CLI talks to. And over here, what we have is auto inject enabled, meaning that any new pod or container or any new pod that is deployed in the Kubernetes cluster, NGINX Service Mesh will keep watching the APIs, Kubernetes APIs, and whenever a new pod is deployed, it will inject or modify the YAML file to inject the sidecar proxy. Now, what we have is I want to show the components of NGINX Service Mesh. So in the NGINX Mesh namespace, what I have is some of the components that we discussed in the slide. So Spire is responsible for generating or handling out the service identity for each of the container that's running there. And the agent runs on all the nodes. So in this case, I just have a 2-node cluster, and that's the reason we have 2 instances of Spire running. Prometheus Grafana needs no explanation. They are quite popular for monitoring and Zipkin for distributed tracing. So what we have is 2 other components that are NGINX components, which basically is the control plane, which talks to the other other components. And Nets it's a message queue similar to RabbitMQ. So Nets is used for communication between all these components. Now, I keep talking about injection. Now, what does that mean, right? So what we have is, let's say, a simple YAML file, and in this case, what I have is a deployment with a port spec for containers. So in this case, I just have one container which has a NGINX image running, and all it does is it will pass the traffic to another service inside the cluster. So when we want to inject a sidecar, what normally happens is that we just want to add another container in the YAML file. And the way to do that is using mesh control inject command. And now this is a manual injection. For auto injection, we don't have to do any of these. And now when I do this, it basically takes the old YAML file, modifies it to add a init container. So what init container does is that it will basically trigger when the pod starts, init container will start, and it will set up the networking so that the traffic is routed through the sidecar proxy, and it deploys a sidecar proxy over here. All that is done automatically. It talks to the Spire using local socket, so to get the certificates from the Spire agent that is running on the node. And that's pretty much how it looks like. So if we look at some of the ports that are deployed with the auto injection enabled, so in this case, I have a book info application that is running, and as you can see, there are 2 containers in each pod. Now, if we look at, let's say, if we describe this container, this pod, right? What we have is again a sidecar that is running, and then there is an init container which is terminated because it set up the networking, and then the job is done, it will then terminate itself. So what we have is eventually 2 applications that are running. One is the actual microservice, and the other one is the proxy, which is NGINX. So now let's take a look at how we can configure traffic policies. So what I have here is the same application that we saw earlier. Now it sends a simple response with the version number. We are sending a request every 1 second. Now in this case, what I'll do is I'll basically change the split, and what I have is a service which basically sends a 500 errors. So just to see, how we can monitor any error rates in the service. So I'll apply the traffic split over here, and there is an NGINX Mesh Control top command, which shows the stats of how each service is performing inside a particular namespace. So in this case, what we can see is that the incoming request, all the requests hitting to version v2 are failing, because it's sending out the 500 error response, and all the services for all the requests for target v1, they are passing. So let's change the split, and point it to version 2.1, which is, again, it's a service that is sending out the same version number, for which it's configured. So we should see the traffic that's pointing towards the version 2.1. We can see that the 100% of the incoming requests, they are successful. Now, in order to visualize these statistics in a much more, I would say, intuitive way, what we have is all these metrics. They are exposed to the Grafana instance that is deployed along with the service mesh. So what we see over here is the details of request, and we can filter it out for each particular microservice. And in terms of success rate, what we can also do is we can see, like, even for a particular version of a microservice, we want to see if the request is successful or failed. We can do that using Grafana. And of course, because there is NGINX instance that is pushing out those metrics, and there are dashboards available for monitoring NGINX instances. So let's say you want, in this case, it's a ratings API or ratings microservices. Now you want a comprehensive picture of all the things that NGINX exposes, things like server latency, client latency, and all those things. Then it's easy to import the dashboard, NGINX dashboard, and then map the instance to a particular dashboard to have a more comprehensive view of what's going on inside any particular microservice. And then the last bit is that I want to show is Zipkin. So Zipkin is used for distributed tracing, and what I have here is some of the traces that I generated earlier. So the whole idea is that each proxy will add a request ID or a trace ID, and then the trace ID is passed along the path. So we have a full visibility of end to end how the request went through which services, and this is particularly useful during the development time, because sometimes you fire a request, it doesn't hit the other microservice, and everyone is puzzled, like, where is it going, right? And those kind of situations, because sometimes due to misconfiguration or development environment, it could be possible that there is a temporary IP address or a FQDN someone entered in the config, and then they are testing with that. With this kind of a setup, it gets very easy to pinpoint where the problem is, and we can even look at the entire duration the request took, and we can break it down further and see which service or which path took a long time, and can maybe go ahead and optimize that kind of particular service. Now because this is all open systems, can be the same set of traces can be then used by some other tools like Jaeger, or yeah, Zipkin is again one of the tools that can be used to visualize it. So the meaning is that the data is all there, probably with the systems that you are already using, things like Prometheus or Zipkin. So yeah, with that, I would like to switch back to the presentation and highlight a certain question when you basically want to go and do a deep dive in a service mesh setup. So with all these features, right, it sounds like it's an answer to all the problems, but that's not the case, because there is of course going to be some additional I would say operational complexity that are there. So um, if you have a very less number of microservices, right, then it may be a bit of an overkill, I would say. You can still get a meaningful metrics, let's say, just using the ingress controller, right? But if you have, let's say, lots of services, then that's where service mesh basically, makes a lot of difference in terms of both, the operations endpoint side and also from the development point of view. Now, with that said, how do you know when to, go for microservice, sorry, when to go for the service mesh in your setup, right? So from our experience, what we have figured out is that, there are certain, I would say, things that you can check, like, things like, do you have a mature CI/CD pipeline? Are you doing automated builds, automated deployments? If that's the case, then definitely a service mesh will be required in future, right? Because you are already taking the path where you may have lots of services, you are already automating the deployments. So that's, yeah, in that case, that definitely is a good sign that you need a microservice or service mesh setup. The other thing is, of course, there are microservices. If there are no microservices, no point in deploying it, right? But if there are microservices, lots of them, then service mesh will definitely be beneficial. And the other part is, if the deployments are not frequent, let's say you have microservices, let's say you have Kubernetes, everything, but you are not deploying, let's say you are deploying very rarely, then there may not, the manual configuration may still be okay. Service mesh wouldn't hurt, but yeah, it may add the additional layer of, a bit of complexity over there. Now, if you have a zero trust kind of environment that you are planning to achieve, or you are in a process of going towards that direction, then definitely service mesh helps. And the visibility part, where you want to have, complete visibility of everything that happens between the services, then that definitely where you should get a service mesh. Now, in order to try it, NGINX Service Mesh is available free for download, can be used today. It's very easy to, get up and running. You just have to set up the NGINX Mesh control command on your system, and then, download the Docker images, push it onto your registry, and then point the NGINX deploy to the registry. So yeah, that sets up the NGINX Service Mesh with the auto injection enabled. So all your services will be by default, protected and monitored. So yeah, that's all from my end. I would love to, answer any questions that you may have.
Yeah, so we've gotten some great questions in so far, but there is time. If you do have a question for Ravi, go ahead and use your GoToWebinar control panel, and we'll get to as many as we can. Let's go ahead and dive right on into the ones we have. Okay, the first one, is it always open tracing or some proprietary protocol to check the traffic?
So with NGINX proxies that are running, they send the open tracing, traces. So you can use it with any of the tools, open source tools.
Excellent. Okay, great. Next question. What are the advantages to using the NGINX Services Mesh over the AWS App Mesh that utilizes the Envoy proxy?
Right. So most of the service mesh, right, in terms of what they do, they pretty much all of them try to do the same thing. They all of them, they have different kinds of design principles, where some of the service mesh are more focused towards enterprise users, some of them are more focused towards developers, and NGINX, basically NGINX Service Mesh is targeted more towards DevOps, kind of a persona, where we want the service mesh to be lightweight, so it doesn't add on your resources, and it also is easy to integrate in your CI/CD pipeline. With things like, AWS App Mesh, if you have a cluster that is running in different kinds of environments, then yeah, I'm not sure how that would work, right? In case of NGINX Service Mesh, because it's completely running inside the cluster or the control plane also, so you can run it on pretty much any kind of environment where it's either it could be on-prem cloud, or migrating between the vendors is also easy in that case. So yeah.
All right, great. Next question. Hello, are there particular conditions when one would not want to deploy a service mesh or a few services on a service mesh, despite having the option to deploy on a service mesh, perhaps due to operational overhead or some other reason?
So if I think one of the reasons would be where you don't want a service mesh is, as I mentioned, if you are not doing a frequent deploys, I think I still feel that the monitoring aspect can be useful. But let's say you already have a monitoring system in place, you are not doing a frequent deployments, and yeah, you pretty much know what's happening inside the cluster, then introducing a service mesh may not be that beneficial compared to the operational overhead. But let's say if you the good side is that you don't have to do it cluster wide. So NGINX Service Mesh or any other service mesh for that matter can be deployed for a specific namespace. So let's say if you are planning to deploy or onboard a new set of microservices, and then want to just test the waters, then can be done in the existing cluster for a specific namespace.
All right. Great. Guys, plenty of time. If you do have a question for Ravi, go ahead and use your GoToWebinar control panel. Get it on in, and we'll try to get to as many as we can. Here's the next question for you, Ravi. At present, we use Docker Swarm instead of Kubernetes. We are a lean team, and Docker Swarm works great for us. The stack is Docker Swarm, Traffic, Prometheus, Grafana, Elasticsearch. So how does NGINX fit into this? Or maybe Traffic does the job for us what NGINX Plus would do?
Right. So I think for the data proxy, the data part of it, right? Data proxy pretty much will do the layer 7, routing and all those things, be it Traffic, NGINX, or any other data proxy. With what happens is that because the NGINX Service Mesh normally depends on the Kubernetes API for a source of truth. What happens is that with Swarm, it doesn't get the state of the cluster. But NGINX Plus can still be running as a proxy, and because even the standalone NGINX Plus can send the metrics to Grafana and Prometheus and do distributed tracing. So can be deployed individually with each service and achieve pretty much the same thing as Service Mesh, but that has to be manually done. Yeah.
All right, great. Next question here, does it work like an APM?
So there may be some overlap. However, APMs are generally more towards collecting stats from the runtime. So for example, let's say you have a Python and a Java application running, they inject or they get the stats from the runtime to give you a much more detailed view of threads and memory consumption and all those things. On the other hand, NGINX Service Mesh will basically collect the operational metrics, so things like latency, any error rates, all those things, and show it in terms of a larger picture, like how the communication or how the traffic flow is between the services. So APMs are more I would say specific or more detailed view on the microservices. Service Mesh is more comprehensive view of the application.
All right, great. Next question here. Okay, is there an online environment read-only to play with?
So we don't have a online environment where you can directly go and test the commands, but setting it up and removing the the CLI or the NSM from the cluster is just one command. So yeah, I would encourage to download it and try it. It runs even on the Minikube on your own system. So yeah.
All right, great. Is it open source or licensed?
So it has some components which are available as free. It's not open source, but it's available as free as in free to use. Should be downloaded from the NGINX downloads.f5.com.
All right, great. So we are just about 6 minutes, oh, sorry, 5 minutes to the top of the hour. So we'll do 1 or 2 more questions and then we'll close it on out. Next question, I have an API gateway and expose all of my interfaces through APIs. Do we use Service Mesh or an API product?
Right. So I think in that case, it's going to be much more, because if the APIs are exposed to the external consumers, then a service mesh is pretty much outside it's more of into the how your services communicate with each other. So that's definitely some API management solutions, or something like ingress controller can still be used for API gateway function as well. Yeah.
Okay, all right, great. Well, that is about all the time that we have for the question and answer period. If we didn't get to your question, I apologize, but please note that the folks at NGINX will be getting a copy of all of the questions that came through, and I'm sure somebody from the organization will be happy to follow up with you offline to get your question answered. Also want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, I did note at the top of the hour that we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and do that. Our winners today, let's see, first one is Michael M. Congratulations, Michael. Second winner today is Peter V. Congratulations, Peter. Third winner is Randy B. Congratulations, Randy. And our final winner today is Osiris M. Congratulations, Osiris. We'll be following up with all 4 of you via email to get your Amazon gift card over to you. So please check your inbox. If you don't see anything in your inbox, please check your spam folder. Ravi, thank you so much for a great presentation. Lots of great information. I'm a big fan of the demo, so I especially love watching those. So thank you very much for including that in the webinar. Really appreciate it.
Thank you.
Yeah, great. Also want to thank the audience for joining me today. This has been a great webinar and a great time, and I appreciate everybody's time. And but for now, this is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.